In section 3.7, we look at quadratic, polynomial, and rational inequalities. But first, let's review linear inequalities. Consider the example here. First of all, how do you know this is a linear inequality? Well, the answer is that every variable x is raised to the first power. And even when we multiply everything out, x will still only be raised to the first power. So to solve this, we simply distribute to get rid of the parentheses. And we can do this on both sides. So right here, be careful, right? You do not want to add 5 and 3. Instead, you would like to distribute here, which gives you 5 plus 3x minus 12. And now we can combine like terms. On the left-hand side, 4x plus 2x is 6x. Minus 12 is less than. And on the right-hand side, we have 5 minus 12, which is negative 7. So we have 3x minus 7. And then we can subtract 3x from both sides of the inequality, which gives us 3x minus 12 is less than negative 7. And now we can isolate the variable on the left-hand side, which will give us 3x is less than 5. And once you have that isolated, we can divide by 3 here to get x is less than 5/3. So the solution on a number line is all of the numbers x that are less than 5/3. So that is every number to the left of 5/3. And that means our answer in interval notation is all the numbers from negative infinity up to 5/3. And this is how we solve linear inequalities. It's a relatively simple process. We simply gather all of the variable terms on one side of the inequality, preferably the left side, and the numerical terms on the right side. And when you do that, you essentially have your answer. So how are these polynomials different? Well, basically, if you have a quadratic inequality, you will have x to the second power. If you have a polynomial inequality, you could have x to any power greater than 1. And with a rational inequality, not only can you have powers of x greater than 1, but you will also have fractions. So let's go ahead and take a look at some examples. In this problem, we would like to solve for the values of x that satisfy the inequality 2x squared minus 3x minus 2 is greater than 0. The first thing you want to do when solving one of these is to make sure that you have the number 0 on the other side of the equation. So one of these sides of the equation has to be 0. After that, we're going to treat this much like we do an equation. So we're going to factor 2x squared minus 3x minus 2. And again, I won't get too much into the factoring here, but I would say it's fairly safe to say that this factoring is relatively straightforward. So now we have the factors 2x plus 1 and x minus 2, and we're multiplying those, and we want this to be greater than 0. Now think about the following. We are multiplying a number here with a number here, and we want that result to be greater than 0. Greater than 0 means positive. So what we're saying is when we multiply these two numbers, we want the result to be a positive number. How do you get a positive number? Well, if you're multiplying two numbers, a positive number times a positive number is a positive number, and a negative number times a negative number is a positive number. So the only way this is going to work is when both of these are positive at the same time, or if both of these are negative at the same time. So the whole problem comes down to figuring out where these factors are positive or negative. So to figure that out, what I'm going to do is first figure out where are these factors equal to 0. And so to figure that out, I'm going to set each one of these factors equal to 0, just like you would if you were solving an equation. And then solving for x, we find that x is negative 1/2 here, and x is 2 for the other one. Now what I'm going to do is draw a number line, and I'm going to put both of those numbers on this number line, making sure that I put them in the correct order. And you'll notice that this divides up our number line into 3 regions. We have all the numbers that are less than negative 1/2. We have the numbers that are between negative 1/2 and positive 2. And we have all the numbers that are greater than positive 2. And we want to know which of these numbers satisfy the original inequality. Now what we can do is we can pick a test number from each one of these regions. So when I look at the region where x is less than negative 1/2, I'm going to pick a representative from that region. And so you can pick any number that is less than negative 1/2. I will choose negative 3. And then I'm going to pick a number that is in between negative 1/2 and positive 2. And the number that I choose here is x equals 1. And finally, I'm going to pick a number that is greater than 2. And the number I choose for this is x equals 7. Now again, these are random choices. Just make sure that the number that you select is a number that is in that particular region. And then what I'm going to do now is I'm going to test each one of those numbers by plugging it into the factored version of the inequality. So I'm going to plug each of these 3 numbers, one at a time, into this inequality to see if it's true or false. So I will start by testing the number negative 3. If we plug in x equals negative 3 into here, we get 2 times negative 3 plus 1 times negative 3 minus 2 is greater than 0. And I like to put a question mark here because we're trying to determine if this is true or not. Simplifying, we have 2 times negative 3 is negative 6 plus 1, which is negative 5, multiplied by negative 3 minus 2, which is also negative 5. And we want to know, is this greater than 0? And yes, this is greater than 0, right? Because negative 5 times negative 5 is positive 25, and positive 25 is greater than 0. So off to the side here, I'm going to write, this is true. So that means that when you plug in the number negative 3, it works. It satisfies the inequality. But remember, negative 3 was a random representative from all the possible numbers less than negative 1/2. So if negative 3 works, then all of the numbers here are going to work. And so that means that all the numbers that are less than negative 1/2 are part of our solution. I also want to point out that when you plug in negative 3, notice that you get a negative times a negative. And in the beginning, we said that that was one of the ways that we will get a positive number, is by multiplying a negative times a negative. Let's test the next region. So I'm going to test to see if this region is part of our solution by plugging in the representative x equals 1. So if I plug x equals 1 into our inequality, we get 2 times 1 plus 1 multiplied by 1 minus 2. And we want to know, is that greater than 0? Well, 2 times 1 plus 1 is 3, and 1 take away 2 is negative 1. Is this greater than 0? And the answer here is no, it is not greater than 0, so this is false. And the reason it's not greater than 0 is because 3 times negative 1 is negative 3, and negative 3 is not positive. So these numbers in between negative 1/2 and 2 do not work. Finally, I'm going to test the last interval here by plugging in x equals 7 as my representative. When I plug in 7, I get 2 times 7 plus 1 multiplied by 7 minus 2. Is this greater than 0? Well, 2 times 7 plus 1 is 15. 7 take away 2 is 5. Is this greater than 0? And the answer is yes, it is, right? Because 15 times 5 is 75, and that is greater than 0. So all of the numbers to the right of 2 also satisfy the inequality. And I like to call this the test point method. So what's our answer? Well, it is all the numbers to the left of negative 1/2 or all the numbers to the right of positive 2. And so our solution here will be all the numbers from negative 1/2 up to 1/2 union all the numbers from 2 to infinity. Now, before we move on, I want to show you an alternative method that we could use for solving this. And real quick, I forgot to put the negative on the 1/2 here. So let me correct that. All right, there we go. That's better. So our solution is, once again, this in interval notation. Okay, so let's do the problem again, but let's use a slightly different method. So here I have the original problem, and then I factored it just like we did before. And then we will set it each factor equal to 0. This is an indispensable part of solving the problem. We have to get these two numbers. And then I'm going to make a number line with those two numbers on the number line, like we did before. And now what I'm going to do, after we divide it up into our three regions, is I'm going to consider what each of these factors behaves like on each one of these intervals. And I'm going to start with the factor x minus 2. So off to the side here, I'm going to put the factor x minus 2, and we'll divide this up into a couple of parts here. You'll get used to the process. And what I want to know is whether this factor x minus 2 is positive or negative on each of these three intervals. So think about what that means. Let's focus on this interval here. Is x minus 2 going to be positive or negative when you plug in a value of x that is greater than 2? Well, it's going to be positive, right? Because if you pick a number bigger than 2, such as x equals 5, 5 minus 2 is positive 3. If I pick a number like x equals 3, 3 minus 2 is positive 1. Anytime I pick a number that's bigger than 2, when I subtract 2 from that number, it is going to be positive. So x minus 2 is positive for any value of x greater than 2. Now, when I plug in a value of x here in between negative 1/2 and 2, it is no longer going to be positive. It will be negative for these values. Just think about it. If you plug in a number that is less than 2 and you subtract 2 from that number, you are going to get a negative. Same thing for this interval. If I plug in a number that is less than negative 1/2, pick any number less than negative 1/2, when you subtract 2 from it, it will still be negative. So what that tells us is that x minus 2 is positive when x is bigger than 2, and it's negative when x is less than 2. Now let's do the same thing for the other factor, which was 2x plus 1. Is 2x plus 1 going to be positive or negative when you plug in a value bigger than 2? And again, just pick any value like x equals 5. If you plug in 5, 2 times 5 is 10 plus 1 is 11. So if I plug in any number that is bigger than 2, 2x plus 1 will be positive. What about values of x between -1/2 and 2? Well, for this factor, it will still be positive here. And it's positive here because if you pick a number that's bigger than -1/2, such as 0, right? 2 times 0 is 0, plus 1 is 1. You can see that it's going to give you a positive result. However, when I pick a value of x less than -1/2, it is now going to be negative, right? And again, you can just pick any value that you want, such as x equals -3. If you plug -3 into this expression, you're going to get a negative. So now, what about the whole thing, right? We're interested in when is 2x plus 1 multiplied by x minus 2, when is that going to be positive? And so now all you have to do is look at your intervals here, and you can see that when you plug in a number that is less than -1/2, you will have a negative times a negative. Well, if you multiply two negatives together, that is going to give you a positive. In the middle here, if you multiply a negative number times a positive number, that is going to give you a negative number. And finally, if you multiply a positive number times a positive number, you will get a positive number here. Now, we want to know, when is 2x plus 1 times x minus 2 greater than 0? And remember, greater than 0 means positive. So it is going to be positive here and here. And those values of x are all the values from -infinity up to -1/2, union all the values from 2 to infinity. So this is another way to approach the problem. Some students prefer this over the test point method. Now, one thing that I will say is when we normally do this, we don't write the words negative and positive. We usually will just put a negative sign or a positive sign. And so if you do that, this is what it looks like. And writing it like this just saves us a little bit of time. So again, when you plug in a number less than -1/2, the factor here is negative and the factor here is negative, but a negative number times a negative number is a positive number, right? In between here, this factor is negative, but this factor is positive. A negative times a positive is a negative. And finally, over here, both factors are positive, and the product of two positives is a positive. And one final thing that I will say here is that if you were solving this problem, where you wanted to know when is it less than 0, now you would be looking for a negative, right? So now your work would all be the same, but your answer would actually be these values of x, because in between -1/2 and +2, the product of these two factors is negative, right? So now this would be your solution. So, your solution is dependent not only on your factors, but also whether you have a greater than 0 or a less than 0. All right, let's go on to some other examples. Okay, so solving this next problem, and for all examples from here on out, I'm going to use the interval method as opposed to the test point method, as I do find the method to be a little bit more efficient. So here we would like to know, when is x cubed minus 2x squared minus 3x less than or equal to 0? So first things first, make sure you have a 0 on the other side of the equation. That's good that we do here. Next step, we'll go ahead and factor. So I can take out a greatest common factor of x on the left-hand side. And when I do that, I can continue factoring the quadratic factor here. And now we have it completely factored. Next thing we do is we set each one of those factors equal to 0. And we solve. So here we get x equals 0. For the second one, we get x equals 3. And for the third one, we get x equals -1. And then I am just going to put those on a number line, those three values. Make sure you put them in order. So -1 should be farthest to the left, and then we have 0, and then finally 3. And this divides up our number line into 4 regions. And then for each one of these regions, I'm going to talk about the behavior of each of those factors. And I'll write those factors off to the side over here. So first we'll look at the factor x. So that will be represented here. Then we will look at the factor x minus 3, which is here. And lastly, we will look at the factor x plus 1. And inside of all these little boxes here, we're going to put a plus or a minus sign to indicate whether that factor is positive or negative on that particular interval. Now, one thing that will save you a little bit of time here, let's start with the last factor here, x plus 1, is think about when is x plus 1 equal to 0? Well, it's equal to 0 when x is negative 1, right? That's where that number came from. So if I plug in any number to the right of negative 1, like if I plug in x equals 2, for example, that's going to give me a positive number. If I plug in x equals 5, I get a positive number. If I plug in x equals negative 1/2, I still get a positive number. So anytime I plug in a number to the right of negative 1, I get a positive number. So I can fill in positive signs for all of these. And if I plug in a number to the left of negative 1, that factor will be negative. Okay? Now I'm going to do the same thing for the other two factors. So for x minus 3, we know that x minus 3 is equal to 0 at 3. So if I plug in a number to the right of 3, such as plug in x equals 7, that's going to give me a positive number there. But if I plug in any number to the left of 3, no matter where I am here, those are all going to be negative. And you can pause for a second here and double check what I'm saying, but just pick any number from any one of these intervals, plug it into x minus 3, and verify that you do get a negative number when you do that. And finally, we can look at the factor x. X gave us 0, and so that is right here. And if you plug in any number to the right of 0 into x, of course, you are going to get a positive, right? Because it's just x. So if x is positive, the factor will be positive. And if you plug in any number to the left of 0, you will get a negative. And so that's a real quick and easy way to get the signs for all of those factors. Now remember, what we're doing in this problem is we're multiplying x times x minus 3 times x plus 1. And when you multiply all of those together, you just need to consider what the sign is going to be by looking at the signs of the factors. So we'll start over here. If you multiply a positive number times a positive number times a positive number, you will get a positive number. But if you multiply a positive times a negative times a positive, that will give you a negative. Here, if you multiply a negative times a negative times a positive, this will be a positive. And finally, the product of a negative, and a negative gives you a negative. Now, what's our answer going to be? Well, it depends what they were asking us, right? They wanted us to solve for when this polynomial is less than or equal to 0. Less than or equal to 0 means negative or 0, right? So we're looking for the negatives. That's going to be our solution here. So where is the product of those three things negative? Well, that happens here and it happens here. So our solution is going to be all the values of x here or all the values of x here. But then there's one last thing, and that is that you have less than or equal to. So in this case, we are going to fill in these circles. These will be solid dots because the endpoints here should be included. And so our answer in interval notation is all the numbers from negative infinity to negative 1, including, union all the numbers from 0 to 3, including. Now let's consider an application. So here it says a box with a square base and a height that is 3 inches less than the length of one side of the base is to be built. What lengths of the base will produce a volume greater than or equal to 16 cubic inches? Okay, so we have a box, and that box has a square base, and so I'll say that the length of this side of the base is x, and the length of this one is also x. And then the height of the box, they said that the height, is 3 inches less than the length of one side of the base. So 3 inches less, so if these sides are both x, then this side here would just be x minus 3. And we know that the volume of the box is found by multiplying the length times the width times the height. Well, the length is x, the width is x, and the height is x minus 3. So the volume of our box is x squared times x minus 3. Okay, so that's the setup. And now the question is, what lengths of the base will produce a volume greater than or equal to 16 cubic inches? All right, so we want the volume to be greater than or equal to 16. But we know the volume is this expression, so that means we need x squared times x minus 3 to be greater than or equal to 16. Okay, so this is the inequality that we need to solve. Now to solve this inequality, remember, you need to have 0 on one side, so I'm going to go ahead and multiply this out. This gives us x cubed minus 3x squared greater than or equal to 16. And then from there, I'm going to subtract 16 from both sides so that I can get 0 on one side. And now from here, to solve this, we need to factor this. Well, how do you factor that? It's not a quadratic, so it's not quite so simple. To factor this, I'm going to use synthetic division. So I will set up a synthetic division problem over here. So we have 1x cubed, negative 3x squared, 0x, and negative 16. And then I need to try to think about what numbers can I put in here. Well, I have to use factors of 16. What are the factors of 16? Well, 1, 2, 4, 8, and 16. So as I always do, I'll start by trying to guess the number 1, and let's go through the synthetic division process. 1 times 1 is 1. 1 times negative 2 is negative 2. And 1 times negative 2 again is negative 2, and this is negative 18. And we did not get 0, so this is a failure, right? Not a bad thing, it happens. So now we have to erase this work since it did not produce what we wanted. And we have to guess a new number in the box. So maybe I'll guess x equals 2. Well, let's go through the process. 2 times 1 is 2, and then we add. 2 times negative 1 is negative 2, and then we add. And 2 times negative 2 is negative 4, and we add. And once again, this is a failure because we did not get 0. Okay, so we go to the next factor. Hopefully, we'll find one that works pretty soon, right? The sooner it works, the better. So next, I will try x equals 4. Let's go through the process. So 4 times 1 is 4. Negative 3 plus 4 is 1. And 4 times 1 is 4 again. 0 plus 4 is 4. And here we go. 4 times 4 is 16. And negative 16 plus 16 is 0. So this is a success. All right, so what does that tell us about our factorization here? Well, it tells us that we know that this factors into x minus 4, right? That's the factor we get from here, and then multiplied by 1x squared plus 1x plus 4. Now, if you try to use the quadratic formula to solve this, you will find out the solutions here are non-real. All right, so since those solutions are non-real, when we go to solve the actual inequality, we don't have to really take this into account because this factor is either always going to be positive or always going to be negative for all real numbers of x. In this case, it's always going to be positive. I'll show you in just a second. So now we need to come back and make a number line so that we can solve this problem. All right, so here is our number line. I put our important number 4 on that number line. We know that x minus 4 is going to be positive when you plug in a value of x greater than 4, and it's going to be negative when you plug in a value of x less than 4. Now the question is, what is this factor? Remember, its zeros were non-real, which means that you can't factor it using real numbers, which means the zeros don't show up on the number line. But we still have to indicate whether it's positive or negative. Well, if you just take a sample value for x, take x equals 5, and plug it in, you'll notice that when you plug in 5, you get a positive number here. And pick a sample value less than 4. For example, you could pick x equals 0. If you plug in x equals 0, you get a positive value here. So because the zeros of this factor are complex, it never changes from positive to negative or from negative to positive. So in this case, it's always positive. Now, what did we want to do here? We wanted to know, when is the product of these two factors greater than or equal to 0? That means positive. So when you multiply these factors together, a positive times a positive is a positive. And here, a negative times a positive is a negative. So the answer that we want is the positive answer, and that is going to occur for these values of x. So x has to be a number greater than 4 or equal to 4, because remember, we did have the equal to sign there. So what does that mean in the end? It says, what lengths of the base will produce a volume greater than or equal to 16? Well, remember, the base was the x and the x. So we know that the lengths of the base has to be greater than or equal to 4 inches. Next, let's solve a rational inequality. The good news with a rational inequality is that you pretty much solve it the exact same way that you solve a polynomial inequality. So we have x squared minus 9 over x plus 5. That's a rational expression, and we would like to know, when is it greater than 0? So as always, you want to make sure you have 0 on one side before you start factoring, and we do, so that's good news. And so what we're going to do now is just factor the numerator and the denominator of this fraction. So x squared minus 9 factors into x minus 3 times x plus 3, and x plus 5 is already factored. And then we're going to set each one of these three factors equal to 0, and that's going to give us our three important numbers. So we've done this a few times now. I don't think I need to write down the equations, but when is x minus 3 going to equal 0? When x is 3. When is x plus 3 going to be 0? When x is negative 3. And finally, when is x plus 5 going to be 0? When x is negative 5. And then from there, we make a number line. On that number line, we put those three important numbers in order from least to greatest. And now we just need to figure out when is each of those factors positive or negative with respect to each of those intervals. So we have the factor, and it doesn't matter what order you put these in. I'll just start with x minus 3. And then we have the factor x plus 3. And finally, we have the factor x plus 5. And just like before, I'm going to fill in on the number line with positives and negatives to indicate whether each of those factors is positive or negative on each of those intervals. And I'm just going to throw those signs in there. And then if you need to, you can pause the video to double check what I'm doing. And so there it is. So I'll pick one of them just to explain, just to make sure we understand. X plus 5 will be negative when you plug in a number less than negative 5. But it will be positive when you plug in any number bigger than negative 5. And we do this for all three of these. And now you got to think about what you're doing with those factors. Well, you are multiplying two factors together and then dividing by the third factor. And we want to know when is it greater than 0, which means positive. Well, if you multiply or divide three negative numbers, you get a negative number. If you multiply or divide two negative numbers, you get a positive number. If you multiply or divide one negative with positives, you will get a negative. And of course, if you multiply or divide three positive numbers, you get a positive. So we know that this fraction, this rational expression, will be greater than 0, which means positive, on this interval here and on this interval here. And so on the axis, that is all the numbers in between negative 5 and negative 3, not including, right, because there is no equal to. And then also all the numbers to the right of positive 3. And so our final solution here is all numbers from negative 5 to negative 3, not including, union all the numbers from 3 to infinity. And I really believe that once you get enough practice, you will also be able to solve these problems just as quickly. In our last example, it's very similar to the previous one, except that just notice on the right-hand side, we don't have 0. And that's a little bit more of an issue when you have a rational inequality. So we have 2x plus 5 divided by x minus 2 is greater than or equal to x. We do not have 0 here. So we have to figure out, how do we get 0 there? Well, the way you get 0 is you just subtract x from both sides of the equation. Now, when you do that, on the left-hand side, you will get 2x plus 5 over x minus 2 minus x. And then on the right-hand side, you will get x minus x, which is 0. Okay, so now we have 0 on the right-hand side, so that's good. But now we have to factor the left-hand side. But the problem is we're not ready to factor because we are subtracting something here. So we have to combine these together before we can factor. So the way I'm going to combine these together is I'm going to put this x over 1. And I'm going to move this over just a little bit to give us a little bit more room. And to subtract these two fractions, we have to have a common denominator. So I need to multiply by x minus 2 top and bottom. And then we're going to do the math here. So we have 2x plus 5 over x minus 2 minus, and then up here we have x times x minus 2, and in the bottom we have 1 times x minus 2. And so this is what we have. Now we're going to simplify here. We're going to distribute the x there. So we have 2x plus 5 over x minus 2 minus, and then x times x is x squared, and x times negative 2 is negative 2x. And now I'm going to combine these fractions into a single fraction by doing the subtraction. So on the top, I have 2x plus 5. And then you have to be kind of careful here because this negative gets distributed to each one of those. So I have minus x squared, and then minus 2x is plus 2x. And so you have to be careful with those details there. Now if I put things in order, I have negative x squared plus 4x plus 5 over x minus 2, and then greater than or equal to 0. Okay, so that was a lot of work just to get it down to the point where we have 0 on one side and we have a single fraction on the other side. Now I have to factor this. Now, what makes this a little bit tricky is the fact that we have this negative in front of the x squared here. So what I'm going to do when I factor that is I'm going to pull that negative out. So let me bring that over here. All right, and now we'll go ahead and continue. So if I factor out the negative up here, I'm going to get negative quantity x squared minus 4x minus 5. And then in the bottom we have x minus 2. And now I can factor this. And that is going to be x minus 5 times x plus 1. The factoring there is relatively straightforward. And now you can see that we have our 3 separate factors. And we're going to set each of those factors equal to 0 to get our 3 important numbers. And here, of course, we get x equals positive 5. Here we get x equals negative 1. And here we get x equals 2. And so on my number line, I'm going to put negative 1, and then 2, and then 5. And off to the side, we will put our factors. So we have, in no particular order, we have x minus 5, x plus 1, and x minus 2. And then we're going to decide whether those factors are positive or negative on each of these intervals, just like we have in the previous problems. However, remember you had a negative sign here, and that negative sign is a negative 1, and that is one of our factors. So we have to take that into consideration. Okay, let's go ahead and fill in all the signs to determine where each of these is positive or negative. Okay, so there it is. I dropped it all in there. So just want to point out that the factor negative 1 is always negative, right? It doesn't matter what x is because this factor doesn't have an x. So it's always negative. X minus 5 will be positive to the right of 5, will be negative to the left of 5. X plus 1 will be positive to the right of negative 1 and negative to the left. And x minus 2 will be positive to the right of 2 and negative to the left of 2. So now, what do we want? Well, we want this thing to be greater than or equal to 0, which means positive. And so when you multiply 4 negatives together, that's a positive. When you multiply 3 negatives together, that's a negative. Multiplying 2 negatives together is a positive. And 1 negative, of course, makes a negative. So to get positive, we want this interval here and this interval here. And so that is going to be all the numbers less than negative 1 and also all the numbers in between 2 and 5. And again, notice up here we have greater than or equal to. So the or equal to means we need to include these, right? But you have to be very careful. So can we include 5? The answer is yes. Can we include negative 1? The answer is yes. Can you include 2? The answer here is no, because if you plug in the number x equals 2, you are dividing by 0. and you can never divide by 0. So even though we want to include all of the endpoints because we have equal to here, we cannot include 2 no matter what. So the solution is, in interval notation, all the numbers from negative infinity up to negative 1, including negative 1, union all the numbers from 2, not including 2, up to 5, including 5. So this is our solution here.